Mr. Moore's math class! Good afternoon! That's right, guys. Welcome to Mr. Moore's online math class once again. Like always, we've got plenty to get through, so make sure you've got yourself a piece of paper, a pen, your calculator ready to go. You put your feet up on the couch, and let's get ready to learn. Alright guys, today's lesson is all about rates of change. Now the good news is we've actually spent a whole lot of time covering this topic during our previous lessons. So really there shouldn't be any nasty hidden surprises that we come across today. Now before we get started, what I think is a good idea is that we actually revise some key concepts that we've covered during that previous topic. Right, the very first one that I'm talking about is that when I say rates, it means gradient or vice versa. Let's have a look.
Now when I say rates, you say gradient. Rates.
Gradient.
Rates.
Gradient.
Now when I say rates, you say gradient. Rates.
Gradient.
Now when I say rates, you say gradient. Rates.
Gradient.
Rates.
Gradient.
I tell you what guys, that giraffe is one hell of a lost cause. You really got to worry about some of the people that put themselves up on YouTube. Alright, the next thing that we want to revise through before we get stuck into the lesson is that the gradient of a position time graph is equal to velocity, and the gradient of a velocity time graph is equal to acceleration. Alright, so let's have a look at that one.
If we find the gradient of a position time graph, what you actually find is the velocity. Right? And if we find the gradient of a velocity time graph, what you actually find is the acceleration.
Oh yeah, that's right, I remember all those things now. Now before we go any further in today's lesson, there is one more thing that we need to get right, and that is that if it says find the instantaneous rate, it means you need to differentiate. Okay, so that's kind of like a little rap there, isn't it? If you find the instant rate, you need to differentiate. Yeah, I said find the instant rate, you need to differentiate. Okay, and then there's one more thing, and that is if it says find the average rate, you need to find y2 minus y1 over x2 minus x1. Let's try and put that in a wrap. Find the average rate, you need to y2 minus y1 over x2 minus x1. Average rate, you need to y2 minus y1 over x2 minus x1. Yeah, okay, it doesn't have the same ring, but just remember, if it says find the instant rate, you need to differentiate, and the average rate is the other one. Okay, so let's get stuck into the very first direct example. Let's go.
Right, so the question says, if f of x is equal to x squared minus 2x plus 4, determine a, the average rate of change between x equals 2 and x equals 4, b, a new function that describes the rate of change at any point x, and c, the instantaneous rate of change when x equals 4. Okay, so that's how we got question A first of all. Now the question asks us to find the average rate of change between x equals 2 and x equals 4. Now whenever it says average rate of change, what it's implying is that you need to use the gradient rule. M is equal to y2 minus y1 over x2 minus x1. Alright, so average rate of change means use the gradient rule for that. So yeah, when it says average rate of change, what it's actually implying is for us to use the gradient rule that we learned when we were dealing with linear functions. Now I've been given my two x coordinates, x equals 2 and x equals 4, but I don't actually know my y coordinates. So I need to substitute these 2 points in for f of x. So you've got f of x is equal to x squared minus 2x plus 4. Substitute in f of 2 now, so you get f of 2 is equal to 2 squared minus 2 plus 4 is equal to 4 minus 4 is 0 plus 4 is 4, therefore it has the coordinates 2, 4. Right, substitute in x equals 4 now, so once again write out the function. F of x is equal to x squared minus 2x plus 4. Substituting 4 now, f of 4 is equal to 4 squared minus 2 bracket 4 plus 4, which is equal to 16 minus 8 is 8 plus 4 is 12. Therefore the coordinates at this point are 4, 12. Alright, substituting into our gradient rule, that is m equals y2 minus y1 over x2 minus x1. So we have m is equal to y2 minus y1 over x2 minus x1. Label the points. x1, y1, and x2, y2. Substitute in now, so you've got y2 being 12, minus y1 being 4, over x2 being 4, minus x1 being 2. Gets us 12 minus 4 is 8, over 4 minus 2 is 2, gets us 4. Therefore, the average rate of change between x equals 2 and x equals 4 is 4. Now the next question says, find a new function that describes the rate of change at any point x. Okay, so what it's actually asking for, because remember rate of change means gradient, because when I say rates you said gradient. So therefore what we're actually looking for is to find the gradient function, and to do that we differentiate. So you've got f of x is equal to x squared minus 2x plus 4. Differentiate now, you get f dashed of x is equal to 2 times 1 is 2x minus the power by 1, so you get 2 minus 1 is 1. You don't need to write the 1 there. Alright, next part is minus 2, drop the power of x, and therefore you're left with 2x minus 2. Remembering that when you differentiate a constant, it just disappears. And the last question says, find the instantaneous rate of change when x equals 4. Okay, so it's wanting us to find the gradient at that exact point. When we want to find the instantaneous rate of change, what we need to do is substitute our x value into the gradient function. So that is f dash of x is equal to 2x minus 2. F dash of 4 is equal to 2 bracket 4 minus 2 equals 8 minus 2, which is 6. Therefore, the instantaneous rate of change at x equals 4 is 6. Now, summing up, if the question asks for average rate of change, or the average gradient, it means use the formula m equals y2 minus y1 over x2 minus x1. If the question says find the instantaneous rate of change, it means differentiate or find f dash of x.